Hey, welcome to the CADCAMZEN Lab. Jeff here. So last time we were going to make a training knife for martial arts. We did the design in Fusion. Actually, a big shout out to James on our team because he 3D printed one for me. The grip feels good. We're going to change the profile a little bit and modify the holes a little bit on our finished product. Originally, this is going to be a two video blog, but turns out that we ran into a snag, and the snag is fixturing the knife. It's going to be a little bit more complicated than we originally thought. So we thought we'd stretch this out into a three-piece blog. The first one, of course, was designing the knife. The second one that we're doing now is going to be on fixturing, creating the fixture for it. And then the third piece will be actually milling it. So stay tuned, read the blog, and hope you enjoy it. Thank you.
So we got a 3D printed version of the knife to hold it. Big shout out to James and the team. Check out his weblog, unprofessionalengineering.com. Great stuff there. So the problem with the 3D printer in this case, and that's the problem we had with milling it, is the print bed and the size of our work envelope. So that rectangle is basically the print bed for the 3D printer, and the knife doesn't fit. It's too big. Well, for the print bed, we can actually make it fit if we just rotate the knife. So I'm going to go into modify rotate. I'm going to rotate it about 45 degrees and shift it up and over. And then we're going to be able to fit this knife onto the print bed for the 3D printer. Just a few more modifications, and then that's going to be ready to go. So from there, you can create the STL file and then have people on your team who have 3D printers access to print them out for you. When we transfer the knife to the machine size, or the size of our machine envelope, we run into the exact same problem, except in this case, we've got less travel in Y. And what that means is that no matter what we do, rotating the knife, it's not going to fit. So we're going to have to end up making a fixture to not only hold the knife, but to be able to machine it um, in two operations. We did modify the profile of the knife. We modified the holes and made a few changes there. So now what we're going to see is just a replay of creating that fixture. Basically, we just started with a rectangle. We cut a slot out of it in the middle. So the knives, we're going to cut two of them at the same time, are going to sit on those raised portions. We're going to locate the knife via two of the holes. So I've got bosses for that. And then we're going to screw down to hold the knives in place. So this will become our fixture that we use to hold and machine the knives. Once we have that, I'm going to import my knife. I'm just going to drag and drop it into the work envelope here. And then I'm going to maybe locate it, move it around so it's kind of out of the way. But actually what I'm going to do is I'm going to use the assemble function and just create a joint between the hole of the knife and the boss of the part. And that's going to locate our knife for us. So assemble joint, pick the hole, pick the other one. Now, if you're lucky, it'll put it at the correct height. If not, I can modify it, or in this case, I know that it's exactly a quarter inch up, so it's 6.35 millimeters. And then you can see that we've already got it with both of the knives in there, so I can machine the ends of the knives, each individual end off one side of our fixture. Now that we've got the part designed, we're going to go ahead and do some cam cutter paths on our part. I've already got them created here, so we'll just kind of cycle through them. But basically, we start with an adaptive rough. And in this adaptive rough, we use a 3/8 inch tool um, and a 1 millimeter step over, 10 millimeter step down. On this mill, we're leaving a half mil of stock, both axially and radially. I also use the adaptive roughing to get the flat areas when it's all done. So instead of using the horizontal machining, I can use the adaptive cutter path, just do the flats with an axial stock to lead of 0. Next, we contour the bosses. So I do each boss, I have a little bit of an overlap on it, and I step my way in. And I originally leave a little extra stock, so in case the tool's oversized or we got some other issues, I can go back and machine the boss to the exact size that I want for the hole. So after doing the bosses, I'm going to go ahead and do a chamfer. And if we look at the chamfer, I'm going to bring the tool in. I'm going to hit simulation and just kind of snap somewhere where I want to see the tool. So we can see the tip of the tool is below the chamfer. The tool's exactly on the chamfer. If I go to the chamfer cutter path, so some of those parameters like the finishing overlap, the chamfer width, in this case 0 because I'm exactly, the chamfer's designed in. If the chamfer wasn't designed in, you'd have to give it a size, and the chamfer tip depth. Now we've just got some drilling functions, some center drill, deep drill, and then thread milling onto the part. With the thread milling, it's actually very easy to use once you give it your thread mill tool, and then you pick your holes and give it your depths and everything. Thread pitch is obviously going to be important. And then the pitch diameter offset is going to be based on whether the hole is drawn in the correct size to the major diameter, minor diameter for the thread. And then you can give it multiple step overs on your way in also, which we did in this case. Now, once that's all done, I can do a simulation of all of these cutter paths just by picking one of them, holding the shift key, and then picking the bottom one, so it selects all, just like regular Windows functions. I can go simulate. I'm going to put it on transparent, turn off the toolpath so it's kind of not in the way. Go ahead and hit the play bar or button and let it do its thing, and then I can adjust the speed if I want to go faster or slower. I'll go ahead and move that dialog box out of the way so you see the adaptive roughing clearing the material out. Once this is done, it's going to do the other adaptive just for the floors, and then it's going to do the contour, then the holes, then the thread mill. Thanks for watching, and I hope you enjoyed.